Hello everyone. Thank you for joining today's presentation. Our topic will be online fraud analysis in big data. As we all know, the rise of digital transactions has made online fraud detection a crucial issue. And in this presentation, I'll take you through the key concepts of online fraud and how big data plays an essential role in fraud detection. To start with, let's discuss why online fraud has become such a significant issue. With the growth of use of online banking, e-commerce, and digital platforms, the potential for fraudulent activities has skyrocketed. Online fraud can range from phishing and identity theft to large-scale financial frauds. Big data offers a powerful solution for addressing these frauds. It allows us to analyze massive amounts of data, enabling the detection of unusual patterns, trends that indicate fraud. And the core objective of this presentation is to explain how big data can help in combating this issue, meaning how it can help us to analyze the online data and help us to detect the fraudulent activities. Now, uh, let's see the types of online fraud. Online fraud comes in many forms, and it's important to be aware with the most common types of fraud so that we can, avoid getting caught in that. So let's break down each of these following types. First one is phishing. Uh, In this, fraudsters send emails or text messages pretending to be a trusted company like a bank or online retailer. For instance, a common phishing scam involves sending emails that look like they are from PayPal, asking the users to click a link and enter their login information on a fake website. And after the user enters the details, the fraudster can steal their credentials and use them for their own benefit. Next one is identity theft. This occurs when personal data like social security numbers or credit card details are stolen. For example, during the famous Equifax data breach in 2017, sensitive data of 147 million was stolen, and it allowed fraudsters to create new accounts and take loans on the victim's name. The next one is account takeover, which is when a fraudster obtains your login credentials and often through phishing and takes over the victim's account. In 2020, there was a notable case where cyber criminals gained control over Twitter accounts of high profile figures to promote a cryptocurrency scam. A very famous victim of this fraud was Elon Musk. His YouTube channel was hacked and they were promoting cryptocurrency all over it. So the next one is a transaction fraud. A very common example is when frauds perform illegal transactions using stolen card information uh, or a hacked bank account to an account which is not trackable, like an offshore account. And the next one is e-commerce fraud. E-commerce frauds में क्या होता है? Fraudsters purchase items online which they buy with stolen credit cards or create fake profiles to scam sellers on platforms like eBay or Shopify. And they may also request chargebacks after receiving goods, claiming they never received them. Now, अब इस पूरे पिक्चर में बिग डेटा कैसे आ रहा है, तो इस पे थोड़ा डिस्कशन कर लेते हैं. बिग डेटा के यूज केसेस क्या है ऑनलाइन फ्रॉड डिटेक्शन में? तो द फर्स्ट वन इज प्रिडिक्टिव एनालिसिस. इसमें हम मशीन लर्निंग का यूज करके मशीन लर्निंग मॉडल्स का यूज करके हिस्टोरिकल डेटा हमारे पास जो भी होता है उससे हम पोटेंशियल फ्रॉड को प्रिडिक्ट कर सकते हैं. फॉर इंस्टेंस, E-commerce companies like Amazon use predictive analysis to identify fraud risks. They analyze customer behavior and transaction data to forecast the likelihood of fraud occurring, shopping fraudulent transactions and before they complete. तो मतलब इससे पहले कि कोई और फ्रॉड एक्टिविटीज हो पाए उसके पहले हम उसको प्रिडिक्ट करके उसको काउंटर कर सकें. Second use case is pattern detection. Suppose a customer's usual spending pattern includes small purchases, right? And suddenly there's a huge purchase of like 5,000, and so big data systems can flag this as suspicious. For example, bank use this system to identify transactions by comparing them against historical behavior patterns of the customers. The next one is real-time monitoring. A very good example of real-time fraud detection is PayPal system. PayPal monitors millions of transactions per minute globally and uses big data to analyze patterns instantly. If an account shows a sudden high volume of large transactions, the system flags the transaction and may block it while verifying with the account owner. This allows organizations to identify fraud as it happens or even predict it, reducing both financial loss and damage to their users' trust. Now let's take a look at the various tools for fraud detection. All the capabilities we have discussed so far. Uh, to achieve those, we employ various big data tools in fraud detection, and below are the few examples of these tools. The first one is Apache Hadoop. And Hadoop is a widely used to store and process vast amount of transaction data. For instance, financial institutions use Hadoop to analyze years worth of transactional data to stop patterns of fraud. Hadoop's distributed processing power allows for large-scale data crunching across various sources like ATMs, online payments, account activity, and transaction frequency, etc. The next one is Apache Spark. Now, Apache Spark excels at processing real-time data, which makes it ideal for real-time fraud detection. For example, riding apps like Uber use Spark to detect fraud in real time. Spark processes data from various sensors and user activities such as unusual trip routes, rapid payments, or multiple accounts using the same payment method. Now the next one is Splunk. Splunk is used to analyze log data from servers. A great example is its use in telecommunication industry, where Splunk monitor system logs to detect fraudulent activities such as SIM swap, etc. Splunk helps analyze large volumes of log data in real time to flag any suspicious activities in the telecom networks. The next one is Python for machine learning libraries. Now, Python is often used to build custom fraud detection algorithms. For example, Netflix uses Python, scikit-learn, and TensorFlow to build models that detect account sharing and illegal streaming activities based on viewing behavior and location data. Another one of these tools is SAS fraud management. SAS is often used in banking. One example is its deployment by a large European bank where it detected fraud in a card transaction. Now let's move on to the next slide. In this slide, we will talk about the various challenges we face in fraud detection. The first one is data privacy and security. As we collect more data to improve fraud detection, we also face increasing risk to privacy and security of the user data. The next one is evolving nature of fraud tactics. The fraudsters are constantly finding new ways to bypass the systems that we have built to detect fraudulent activities, making it difficult to stay ahead. The next one is high false positives. While detection systems are improving, they often flag legitimate transactions as fraudulent, which leads to customer dissatisfaction. Next one is integration of multiple data sources. Uh, we have a lot of data in all of various formats. So combining data from various platforms and systems can be complex, and data inconsistencies can affect the accuracy. The next one is handling real-time data. Processing and analyzing real-time data is very resource extensive and requires significant computational power. With this, we have reached the end of the presentation. Throughout this PPT, we learned various types of frauds and the big data systems that allow us to detect and prevent these fraudulent activities. We also saw various challenges we face during detection. And to conclude, online fraud is an ever growing threat, but big data provides powerful tools to combat it. By leveraging machine learning and advanced analytics, organizations can significantly improve their ability to detect and prevent fraud. However, it is important to address various challenges like we saw with, for example, data privacy to ensure continued effectiveness. Thank you.